Hi there. My name is Hugh Rigassio, and this is my phase four of my Engineering 292 final, Intro to SolidWorks, with Professor Jared Berdal. Phase four calls for us to discuss the final project that we made in SolidWorks, which was a drone. And I'll be talking you through my SolidWorks models and things I liked, things I didn't like, things I found challenging, things I found very beneficial to my learning. And yeah, I'll start by walking you through some parts that I was making for each phase, what they recalled, how I overcame certain problems, etc. So this is one of the parts that we were required to make for our phase one. This is the battery connector for the drone and looks really nice, I know. But let's see, where do I start with this one? So this is the second one that I made. I had made one that I didn't like the dimensions of, and or I realized that they didn't line up properly, and before I really assessed what I could do to salvage the model, I just deleted it and started over, losing about 2 hours of progress. And it shouldn't have taken me that long, but because I was still learning how to use SolidWorks, it definitely was a bit of a learning curve. This is one of the more complicated parts that we had to make at the very start, so it took me a while. But this part here, this battery connector, really challenged my ability to go back into a SolidWorks model and edit it so that when I exit the sketch, it performs all the extrusions to adjusted dimensions. And what I really liked about this part was this was really the first one that I did where it required me to lay out my sketches on each axis, like so, and then draw on top of them and extrude accordingly. I had a lot of issues with these dimensions and with these drawings because I found that, oh, not edit sketch, show. So this is one thing I definitely never tried. I never tried drawing over sketches in any SolidWorks or any 3D modeling software prior to this. And what I've really liked about it is it's a very handy way to go from drawings to actual models. But because there were some discrepancies with the dimensions, I found a lot of issues. Sorry, I'm trying to hide the part really quick. Let me see what I can do about that. Battery connector, can I hide it? Um, Extrude one. Okay, let's see if I can hide this. Perfect, there we go. So basically, this is how making this part started out. It was lining up, scaling your drawings in correct measurements, and then making sure that you line up the drawings at a consistent origin so that when you extrude everything out, it's to scale and dimensioned properly. I had a little bit of issues with this because I noticed there was some discrepancies between the dimensions of each drawing. And at first, I saw this as a real detriment to my efficiency with this project because it held me back from just trying to extrude or doing things about correctly because I had to double check with Professor Berdal whether or not it was acceptable to have things be kind of close to scale, not perfect. And at first, when I realized that my drawings weren't properly to scale, not that they weren't properly to scale, but that some of them just weren't the dimensions that we were given didn't match up with the original dimensions of the drawing, so that created some discrepancies when I imported all my images of the drawings, and it caused me to worry about whether or not what I was doing was going to be good enough for the submission of the project, etc. So I frantically asked my professor a lot of questions about it before I realized that we could more or less, it didn't have to be perfect. And doing these models, knowing that they weren't going to be perfectly accurate, I I was really angry about that at first because I thought, oh, well, how are we going to be graded? If everything's arbitrary, how are we going to be graded based on the accuracy of our parts? And at first, I really saw that as a detriment, But then I realized how beneficial that was to my SolidWorks learning afterwards because it taught me how to go back into sketches for prior to extrusions and edit sketches, edit dimensions, change things that you want so that when you exit the sketch, everything is extruded in the way that you want it. So I initially thought that you had to do everything perfectly or it wasn't going to work out and you'd have to restart. But what having a lot of arbitrary values on many of our drawings taught me how to do was improvise, if you will. And I think that is the most beneficial thing I took away from this course by far. I feel so proficient at SolidWorks now, and I really appreciate all the learning that happened over the course of this project. And it gets me really excited to work on more things in SolidWorks in the future. And it taught me that I could I dropped like three other I had a one graphic design software that I was using for laser engraving things, just working in the machine shop. And I realized that you could export drawings from SolidWorks as vectored images. So I don't have to go into a graphic design software that I'm unfamiliar with and, rage over the not knowing how to use the software or not being proficient with the software. And now I feel like SolidWorks is really a jack of all trades. So becoming proficient with this software, I think is by far the most beneficial thing I took away from this class. And at first, I had some doubts on what I was learning, and I realized that not everything being provided, having to make sure you scale out everything so that parts later on line up and everything fits together in the assembly, really taught me how to critically think ahead when designing these parts so that I made sure certain components were the right sizes so that they fit later on. And I was panicking quite a bit at first, but I have to say that it really opened my eyes to how proficient it had made me at SolidWorks. And for that, I am forever grateful. Thank you, Professor Berdal. But enough glazing. Let's move on. So this is how the part ended up. I love looking at parts in SolidWorks. It's like my favorite thing to do, especially when they're completed. But yeah, so this was the battery connector. I had a huge learning curve while working on this part and um, it really set me up. It made me so much faster at doing everything else for the rest of the project because initially, when I was spending around 2, 3, 4 hours per part, I thought to myself, "Oh my God, when is this going to end?" But it really taught me how to work things faster, and every time I did something again, I could do it in less than half the time. But I'll stop. I'll move on to another part because we've been looking at this one for a while. So Command open. So if we go, actually, I'm going to do it from the SolidWorks. Get out of my way. Zoom meeting. Okay, browse recent documents. Let's look at some other stuff that we had from phase one. So I think the base frames are something good to look at. A lot of components had to be attached to this base frame, so making sure that dimensions were consistent with parts that I hadn't even made yet was very important. And even if they weren't, so one thing that I did think of ahead was adding the mounts for the propeller arms, which you can see are these four here, 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 and here. And initially, I thought to myself, oh, right, I made those 10 by 12 millimeters. So when I made the propeller arms, or I think I did the propeller arm first, and then I did the base plate after. So when I was making these holes in the base plate, I was able to control the angle that all the four squares were tilted at, and then I made two construction lines and just made one circle and mirrored them across. So I really learned so much about how to streamline certain processes in SolidWorks, and one of them was definitely just making holes, making cuts, and then not only that, but knowing how if they were wrong to go back into the sketch, um, like so, and then use smart dimensions to reshape everything. One of the examples is these four circles here. These I needed so that I could mount the body that holds the gripper arm on the bottom of the base plate. I didn't think I would need them for anything, so I just kind of made them randomly when I started. But then after I realized that they needed to be a set dimension apart, they needed to be perfectly dimensioned apart from one another. And the smart dimensions are this 30.5 and 30.5 millimeters. But that's besides the point. What I learned how to go back into sketches and then edit them, dimension extrudes and cuts properly, exit. So you can go in here and edit these. Like for example, this one I can just do 30 and then it adjusts the width of those holes. But then I'm going to put it back to 30.5 or else it'll mess up my assemblies. And then, you hit OK, exit sketch, and then your extrusion's all done and you have your holes changed and you can do whatever you want. This has to be one of the most beneficial things I took away from this class because it taught me how to go back and edit items that I already have so I don't have to go ahead and make new ones from scratch. And I've always done that in my 3D modeling career. I guess you could call it career. In my 3D modeling experience, I've always done that, like remade things, scrap drafts. But what SolidWorks helped me teach was what SolidWorks taught me was that I can go back into those sketches and edit them and, really figure out all the niches of the software. So we can get rid of that now. I'm just gonna not save that because I don't need to. So let's open up some other parts. So that was phase one. Really taught me how to go back and edit sketches so that I wasn't wasting too much time making new parts and just trying to do it all over again. And that was super beneficial. So phase two was taking all the parts we had, putting them together in an assembly, and then getting hardware from McMaster Car so that we could line up everything and see what it would look like in all put together and make sure that nothing is conflicting, making sure that everything's shaped well. So I think I'll just go straight to the assembly. So this is the drone assembly. This took me so long, but it's okay. 140 components. I love looking at the feed on the side and looking at how many parts I included. I love looking at this list because it's just the history of your work. And then not only that, but the mates as well, the extensive list of mates. Maybe I could have made these a little shorter, but I didn't realize you could do multiple mates and then before clicking the check mark and then starting a new mate. So when I realized that, again, like realizing that and learning that taught me how to make things much faster the second time around. And yeah, it's super beneficial. Absolutely loved working on this project and forever indebted to the things that it taught me. But we'll keep that on the side for now. But yeah, so this is the model. This is everything in its glory. And I had a super fun time making all this. This is definitely my favorite final so far. This is definitely my favorite final this semester, hands down. And after assembling everything and learning how to use mates and just getting used to SolidWorks and like where to position things before mating them so it doesn't come up with a bunch of errors or do something weird. So it taught me how to be proficient with this software, and that was just so much more. It taught me so much more than just how to make parts by following the instructions perfectly. And because there weren't perfect instructions like a Lego, not to say perfect, but thorough, like as in a Lego set, every single little detail is laid out for you, and it's shown how to perform. With this project, I felt like I was making a Lego set without an instruction manual, or a very limited one at that. And that really taught me how to get good at using SolidWorks and placing all my pieces together. It taught me how to, like, for example, these rods, editing those, I did like that. It was so quick. And that was really fun. Being able to do this stuff really fast was just absolutely amazing. I want to say, you know what? In phase one, I think the most complicated part that I made was these DC motors, but I think I did such an excellent job with them and made them look super close to what the actual manufacturer would have had for these models. And I was really proud of how that came out. It taught me how to use it. It was a very challenging piece, and I was really happy with how that came out. But anyway, so phase two was put everything together, make sure it fits, learn how to do mates, learn how to layer things, make sure everything's locked so that when you grab stuff, it doesn't move, and except for the propellers. And then after that, once we were completed with that, we go ahead and make our motion studies. So the first one that I made was the exploded view. This one didn't take me too long to learn, although actually, I'll go over that in a little bit later because that was more with the rotor spinning simulation. But anyways, this exploded view didn't take me too long, but it definitely was a little bit of a learning curve because at first I was making new exploded views for every part that moved, and I didn't realize I could just scroll down a little bit, hit done, and then go on to the next item that I wanted in the collective exploded view. So that had to backtrack a little bit, which was fine, but ingrained it into my memory, so I'm never gonna make that mistake again. But here's the exploded view. I love watching it. And yeah, that was really fun. It made me realize that my PCBs were 90 degrees incorrectly laid down. So I fixed that. At every phase, I was going back to the previous phase to fix something that I realized was wrong after I looked at it in later procedure. So the entire time I was doing this project, I was constantly going back, editing things, making them better. Um, I liked making things look nice, so that was definitely my like the with the purple, propellers. I didn't need to do that, but it was fun. Um, and then, yeah, I really, there was no part of this project where I wasn't constantly improving on every skill that I'd learned while making it. And that was just super awesome. The second motion study, this one, I was pulling my hair out trying to figure out that in order to reset the model before you run it again, you have to click this little tiny button called calculate, and it was making me lose my mind. And I finally had a friend come over and help me, and he was like, "Dude, you hit calculate?" And I was like, "What are you talking about? I've been hitting the green check mark on the top left. Is that not it?" And he goes, "No, it's right here." And he goes all the way down to this little one and hits calculate. And then in one click, he completely fixed the problem that I was having the entire day. I spent a whole day trying to figure out um, this simulation, and then he just waltzed in, clicked one button, and then immediately all my issues were gone. So that was pretty funny. But here it is. I really enjoyed working on this. I thought it was super fun. Um, and I was very happy that it taught me a lot. Oh, did that last propeller not move? One, two, three, four. Yeah, it's working. Okay, perfect. But yeah, so this is my simulation, and I had a lot of fun making this. I learned so much about assemblies and how to lock pieces together and just all of the nuances of SolidWorks. Sorry, I'm rambling. I'm going way too long. But yeah, that was about it for so phase one was making a bunch of parts. Phase two was putting them together, going back into phase one and editing those parts to making sure that everything fit together. That's where I really learned how important using the editing sketch options were and so on and so forth. And then phase two was assembling everything together, learning how to use the mates, learning how to input more than one object at a time, one part at a time so that I could line it up better. And yeah, that was just super helpful. I absolutely loved working on it. And oh yeah, my bill of materials is down there. But yeah, so basically that was pretty much it for phase two. And I learned a lot from every single phase, and every single phase compounded on the last, but talking too much about it, so let's move on. So let's do open, and let's, oh wait, I'm not gonna do it from there. I keep forgetting I'm not gonna do it from there. I'm gonna do it from here because it looks nicer. So after that was phase three, and phase three was taking parts that we'd already made, making some new ones, and making some drawings for the gripper assembly, which should be somewhere here. Let's use this one. So I had a little bit of a I realized that my servo motor was 24.4 millimeters wide and not 22. But as soon as I realized that when I was assembling this, it was after I assembled it, I realized that my dimensions on that were wrong. And then, but it was a quick fix. I went back, edited my sketches, took me maybe half an hour to fix. And that was really like, I was like, wow, that was so fast and that was awesome. But yeah, this is my model right here. So we can take, oh, it's not really moving so well, but I think it's because I mated those together. But basically, it works well, as you can see. I really enjoyed learning how to do the slot constraint. Although I don't know how to, like, after you mess around with it, I don't know how to make it go back on flat onto the plane. So a lot of stuff that I was doing had to like, I'd go back to a certain point where it didn't save so that it was like it was normally, or when I would, yeah. So I sometimes, a couple times I had to not save the assembly so that I could get it back to the standard isometric views to put on the drawings, which I will open up one of right now. Don't save, don't save. And then I'll do browse recent documents. So we'll do the phase three was making the drawings and making some of the gripper components. I couldn't figure out how to make that isometric view flip the other way around, but it's still an exploded isometric view, so I feel like I won't get docked marks for making it this way. But I really enjoyed learning how to edit the drawings. It taught me how to put bill of materials, simplify and edit the titles and names and everything, and that was super easy. Really enjoyed learning how to do that, and very beneficial. So that was great. And then after that, phase three. So yeah, phase one was making all the parts. Phase two was putting all the parts together, going back into phase one, editing them to make sure everything fits. And then phase three was even more phase two, just for a different assembly. And then I also put it on top of the drone because I thought, why not? Even though it's not required, I still want to do it. And then yeah, and then after that, this is phase four. I think I've done everything correctly. I think I've opened it all up. What I'm really annoyed about is that sometimes as I was progressing with this project, I would realize that certain items that I made didn't have correct dimensions as I thought they did. So I went back and corrected it all with my new SolidWorks proficiency that I was developing on the daily. And it's annoying because I think I'll miss out on some points for the first assignments, but I'm fairly confident that I did everything absolutely correctly now. And if I uploaded it all again, it would get 100%. So please, Professor Berdal, bless me up. I worked really hard on this and I learned a lot and it was awesome. But yeah, I love SolidWorks now. I love being proficient on SolidWorks. It was so enjoyable to do this project, and this is definitely one of the best things I've done all semester. And I'm now going to use SolidWorks. SolidWorks is going to be second nature to me. I love using it. I love getting proficient with it. And I love that it turned from a nuisance to a great learning experience because initially I was really upset that we had to come up with a lot of arbitrary values. But that doing that taught me or really showed me that improvising in SolidWorks and improvising in 3D modeling softwares is such an underrated skill and it's very important and you need to know how to do it. And yeah, I think that that was most of what I learned, things that I ran into. I'm sure I missed over half of the things that I wanted to talk about or that I would talk about, but there was just so much that I learned with this project that I can't even put into an under an hour video. So I'm going to stop here and thank you, Professor Berdal, for this challenge. I really enjoyed it. It was great. I learned so much, and looking forward to using SolidWorks very often in the future. So yeah, thanks a lot, and I hope you have a good day. Uh, there we go. Bye now.